Hi, good morning. Good morning. How are you? Okay, let's wait for some more 1 minute for others to join as well. So I will be waiting for 30 seconds or 1 minute, I must say. And after that, we will be starting with our questions. So I hope you all must have done the question that I have left yesterday. That a spot wala question. Okay, so let's get started. Actually, we are already 1 minute past 10, I guess. Yes. So, okay. So this was the question actually that we left with in yesterday's class. How many of you have done it already, or any one of you want me to do? Let me know. I will be doing otherwise. But if you have done, there is no point of wasting the time. We will be moving ahead with questions ahead, right? So let me know if anyone wants me to solve it. Oh, so much silence. चलो ना का मतलब हाँ होता है, ऐसा मैंने सुना है और ऐसा ऑब्जर्व भी किया है. So if no yes or something is coming, it means I need to solve. Okay, done. So what the question was, there was a point source, and this point source was kept at the bottom of a tank somewhat, and that tank is what, 10 millimeter thick. That is a block actually, that is 10 millimeter thick, and refractive index was given 2.72. It is immersed in a lower refractive index. So yes, namaste, good morning. I hope you all are good. So let's move ahead with this question, okay? So there was a source of light kept at the bottom of the block, and this block was immersed in a media of refractive index, something else that was unknown actually. So let it call N. And what was happening, I explained yesterday that what will happen if I draw a normal here, and if light is incident at an angle that is good morning, that is less than your what, that is less than critical angle, then what will happen in that case? If it is less than critical angle, light will go out. But if further I take normal here, and if angle of incidence is greater than or equal to critical angle, what is going to happen? Light is not going to pass into the media N, right? So suppose this angle is greater than critical angle, it will come inside. Done. Again, this block size we can increase here because my ray diagram is going out of that. So it will look something like that. Done. So that is why what we are going to observe is on the both side, if I am going to draw the block again, then you will notice that up to certain reason, light will come out of the surface. Done. In this region, light will go out, and after that, light will not go out into the media of refractive index N. Why not? Because the angle at which light is incident upon the interface is greater than critical angle, and for that, light will come back to the block. It will not pass into media of refractive index N. So in our question, what was the thing that we needed to calculate? We needed to calculate the diameter, no, the diffractive index of the liquid, and its diameter is given, that is 11.54. Yani ki light is, let me draw now here. So if light is coming out of this region, suppose, so its diameter is given in the question, and its diameter is how much? That is your 11.54. So we can easily see what will be the radius. Done. So up to this point, light is going out. It means if I draw normal at this point, this angle must be equal to the critical angle. Light is going like this. Okay. And here also angle of incidence, if this is light, then it will be critical angle. Light will go on like this. Done. So we need to calculate n. Now, if this angle is critical angle that I have taken as IT, then with vertically opposite angle, you can say this angle will also be IC. Then just see in the diagram. This now only the thing is here, आपको geometry solve करनी है. Nothing else you need to do. Concept is clear, right? So this angle is IC. Again, this height is given in the question. This height is the height of block actually, and that is how much here? That is your 10 millimeters. So this one is how much? 10 millimeter. And this radius is given. This radius is how much? 11.54 divided by 2. So this radius is given. We can calculate the hypotenuse, right? So what will be the value of hypotenuse? That will be equal to 10 millimeter means this much meter ka square plus 11.54 again millimeter tha, 11.54 divided by 2 into 10 to the power minus 3 ka square. Again, you need to calculate it. Done. That pain of calculation you will have to take. Then hypotenuse you will be calculating from there, right? Now what will happen? Sin IC you can write from this triangle. If I call this triangle SOP, so from triangle SOP you can easily calculate sin IC. And what will be the value of sin IC? It will be 11 point. If I go on to calculating sin IC, it will be how much? It will be your 11.54 divided by 2 by H. So sin IC we can calculate from here. Now, if you apply Snell's law at the interface, at that point, at point P, if you're going to apply Snell's law at point P, what you will be getting? You will be getting mu of the block, that is 2.72 into sin IC will be equal to how much? N2. Sorry, N. This light is going into which media? Liquid. So N into sin 90. Why 90? Because for critical angle, angle of refraction is how much? 90 degrees. So sin IC value we will get from here. That value we will put here. And then we will be able to calculate the N. So anyone now, just now tell me what is the value of H here. Go on fast. Let me know what's the value of H here. The one that I have written here. Then we need to calculate it, right? So I have left it upon you. Let me know. Approximately, yeah. Come to the prox value at least. Yes. Anyone? 33.64. Okay. Anyone else? Are you people using calculator? You should not use if anyone is, because in the exam you won't be getting that. I know. We must know how to calculate it very easily. I can also try here. So what I actually used to do is I will take more approximation if that works. So 11.54 divided by 2, it will be close to how much? It will be close to something 1.54 by 2. So that is going to be equal to 5.5 how much? 7 done 5.77. So this one I can take as what? This one I can take as that will be your equal to something 6 I can take. Done. So 6 into 10 to the power minus 3. So again 10 to the power minus 3 ka square we can take as common. So that will come as 10 to the power minus 3 outside. And this is your what? 10 ka square. So this is 100 plus and how much I'm taking this as 36 approximately. So this is root 136. Root 136 will be equal to how much? How much it will be equal to? Root 136. Root 12 is how much? 144. So root 36 will be 136 will be equal to how much? Less than that, no? More than 10, less than that. Yes. So yeah, correct. So this will be equal to how much? 11.2 into 10 to the power minus 3. Done. So this is going to be your value of h. Value of no, but this is coming less. No, done. Clear. So this value of h you are going to get. Now put the value of h and all and do the calculation. Done. Chalo, theek hai. Yeah, you people should be quick in calculation now. When I am doing such sort of calculation, just be ready with your pen and copy and do it, because calculation, if concept is going to be easy in your question, calculation is going to be a bit lengthy or tough or something, but it's not lengthy or tough. Again, you should be ready for the calculation. Clear? Eh? Now I'm giving you another 2 minutes, just 2 minutes you require. Read the question carefully first and please do solve it. It's very easy to solve it. 2 minutes. Yes. Are you people getting the answer? Yes. Yes. Anyone? What problem, what difficulties you people are facing? I just want to know. Here you need to do a very simple thing here. You need to put the effort. Okay. So what the question is, there is a parallel beam of light and this is incident from air at an angle alpha on the side PQ, done. That is shown here in the diagram. And refractive index of this triangular prism is √2. Light undergoes total internal reflection in the prism at the face PR. Done. So if alpha has a minimum value of 45, then what will be the value of theta? That is asked here. At surface PR, total internal reflection is happening. So you just need to draw the ray diagram and then use the Snell's law and a little bit of geometry. So angle is incident here. At this point, what will happen? Light will change the media. So refraction will happen and it is passing from air to some other media. So light will bend towards the normal. So light has bent towards the normal and then it will fall on the surface PR. Now on the surface PR, draw the normal, and what will happen? Light will now at this surface, light is undergoing total internal reflection. So it won't refract into the air. Done. So for now, let it look like this. Now come to the geometry. This angle is theta. And here this is 90 degree. And if this angle is suppose R, angle of refraction, this I am taking as R. So this angle is how much? This is theta, this is 90, this will become how much? This will become how much? This will become 90 minus theta. Done. This angle. Now come to the triangle. Let's call it O, P, and R. So in triangle ORP I'm talking about. So just see what the angle values will be here. So this is 90 minus theta and this angle will be how much? This whole will be 180. So this angle is going to be how much? This angle is going to be 90 plus theta. Done. And this angle is equal to R. Done. This angle is equal to how much? R. So this angle will be equal to how much? That we can calculate. So first, let's calculate the value of R. That is we can do because minimum value of alpha is given. That is 45 degree. So apply Snell's law at O. At O, apply the Snell's law. So what you're going to get? 1 into sine alpha. Snell's law you all know now how to apply it. Okay. I have got one answer, but there is a little bit of problem with that. You need to check that again. Okay. But thank you. You tried. Everyone tried, I guess. At O, if you are applying the Snell's law, what you will write? 1 into sine alpha will be equal to how much? Root 2 sine R. So sine R is going to be how much? Sine alpha by root 2. Sine alpha means sine 45. So that is 1 by root 2 into root 2. Done. So R will be how much? Angle R will be how much? 30 degree. So this angle R is okay. So if you were talking about angle R, then yes, that is correct. That will be your 30 degree. So this is 30 degree. This is 90 plus theta. So this angle will be how much? So angle R plus angle 90 plus theta plus angle P I am asking equal to what? 180 degrees. Simple. Angle R is 30. This is how much? 90 plus theta. And this is angle P, 180 degree. So how much will be the value of angle P? 180 minus 120. That is your how much? 60 degree minus theta. So this is our angle this. So what will be angle this? This angle will be how much? This angle is going to be how much? Just tell me now. This angle is going to be how much? This whole is 90 now. Again at P you consider this whole will be how much? 90. And this is your 60 minus theta. So that is going to be 30 plus theta. Done. So this angle, yani ki angle of incidence at the second surface is equal to how much? 30 plus theta. Now apply Snell's law at P. So if you apply Snell's law at P, yes, once. What value you are going to get? What value you will be getting? So sine 30 plus theta will be equal to how much? Will be equal to this into root 2 actually will be equal to at this surface total internal reflection is happening, and here alpha we have taken as minimum. So here also angle of incidence we need to take as minimum for internal reflection. So that will be how much? For that, if this angle of incidence is critical angle, then angle of refraction will become how much? 90 degree. So here you write sine 90 into 1. Done. So what value we are going to get? Sine 30 plus theta will be equal to how much? will be equal to 1 by root 2. It means 30 plus theta is equal to how much? 45 degree. So theta is how much? 15 degree. Done. So correct answer will be what? A. So you don't need to do anything. You just needed to solve the geometry. You just needed to apply a little bit of concept. What is happening? Alpha value is given. That is 45 degree. That is minimum. So what you needed to solve is at the surface PR, total internal reflection is happening. So simply draw the line like this, do this, and this for this if this is critical angle of refraction will be 90 degree. Why we are taking the critical angle? Because no other value of this angle is given also, and also the alpha taken is minimum. So for this minimum, this also must be minimum through the geometry. You can also see that, but you don't need to check upon that still. Because here, if you are going to put the value of sine, suppose this is not critical angle, then it will be something else, this angle. Here we can't apply Snell's law also. Done. So again, calculation will go into some different directions. But if we assume this thing, and this we can assume to perfection actually, because alpha here is what? Minimum. Done. So I hope that is clear. Now I want you people to solve this question. Please do solve it. Take your 3 minutes of time. Draw the geometry carefully. Stay cool, calm. Just go for it. Done. Do it. Do it. I'm here only. If you have any doubt, you can also write to me in the chat box. I hope you people are solving this. Okay, Pravit, that is true. Again, read the question carefully. यहाँ पे आप देखो, which of the following is R? So multiple options may be correct. So the one that you have given to me is correct. Also check further. Nothing you need to do. You only need to go with the geometry. Total internal reflection questions will involve lots of geometry. Only the concept of is using a Snell's law and remembering that at for minimum angle of total internal reflection, angle of incidence is taken as critical angle. Then, so here, if you have solved it, you must have got like light is incident on the surface AB, right? So start moving from the AB. So I have drawn the normal here. So this is the normal. What will happen? Light will move towards the normal because light is moving from air to where? From air to a medium of higher refractive index. So light will bend towards the normal. So I have bent it towards the normal. Now light will fall on the surface CD. Done. If at P, if you are going to apply what? Yes, Pravit, correct. If at B, you are going to apply what? A Snell's law, P, what you will be getting? You will be getting angle of incidence is given, that is your 60 degree. So at P, I am applying. So what you will be getting? 1 into sine 60, that is your root 3 by 2, equal to sine R into refractive index of this media, that is given as root 3. So R value will be how much? 30 degree from this equation. So this is your 30 degree. This angle is how much? 30 degree. Now come to this quadrilateral, actually BPCO. Let's call it O. Light is falling here. So if you are considering BPTO, so this will look something like this. This angle is your 60 degree. Done. And here there is a normal drawn and the light was incident something like this. Done. So this was your 60 degree. This was your 135 degree. And how much this angle we have got? This angle we have got as 30 degree. And this angle will be how much? 90 degree. So this angle we can calculate, right? So let's calculate this angle. This is 30 plus 90 and 30 plus 90 is 120 degrees. So this whole is 120. This is 60. This is 125. So 120 plus 135 will be equal to how much? 255. And 255 plus 60 will be how much? 315. Done. And sum of all these four angles will be how much? 360. So another angle, that is this one, will be equal to 360 minus 315, and that is equal to how much? 45 degree. So this angle here is 45 degree. Now draw the what? Draw the normal here and try to see what's the angle of incidence is here. So if this is 45, this will become 45. Done, because here we have drawn the normal. This whole is 90, this is 45. So this angle is going to be how much? 45. So for second surface, that is surface CD, for CD, angle of incidence is how much? 45. Done. So check what will be the critical angle for surface CD. Done. So if critical angle is greater than 45 degree, then this light will come out. And if critical angle is equal to or less than 45 degree, what will happen? This light will get totally internally reflected. So for total internal reflection, you know the case now. Angle of incidence must be greater than equal to critical angle. So first try to calculate the critical angle for phase CD. How we will calculate the critical angle? For calculation of critical angle, suppose critical angle is IC. Then at this surface, suppose this critical angle is how much? IC. So I am writing sine IC into a Snell's law. I am applying at surface CD. Refractive index is root 3. So for critical angle, angle of refraction will be 90 degree into 1. So sine IC is going to be how much? Sine IC will be equal to how much? 1 by root 3 something. Done. So sine IC will be what? IC will be what? It will be greater than 45 degree or less than 45 degree. Value of sine 45 is how much? 1 by root 2. Done. Clear as like here you need to like for sine IC equal to 1 by root 3, I can't directly say which angle it is going to take. Done. So we will have to go for the comparison, like for sine 45, value is how much? 1 by root 3. And we know from the sine curve that as angle increases, value of sine what? Increases. Done. So 1 by root 3 is greater or 1 by root 2 is greater? Root 3 is greater than root 2, right? So 1 by root 3 is less than 1 by root 2. Done. So if value is less, it means angle will also be less. Done. So IC is definitely less than how much? 45 degree. IC is less than what? 45 degree. And here angle of incidence is how much? 45. So this is greater than IC. It means light will get totally internally reflected at surface what? CD. So at CD, what is going to happen? Total internal reflection will happen. Now we need to check for the surface AC. Again for AC, do the same thing. Draw the normal here. And again, this angle of incidence, you can calculate from the geometry. If this is 45, this angle will also be like, this was the normal now. So we need to calculate, this will be angle of incidence, this is angle of reflection. So if this is 45, this also be 45. Now light is falling here, draw the normal here actually. So if this is 45, you can calculate this angle, right? Are you getting my point or not? So let me remove the things from here. Let me draw it again there. Okay. So what was happening? Light incident here will get totally internally reflected. So it will fall somewhere here. Again, with the diagram I'm telling actually. A, B, not D. It will be A, B, C. Correct answer is A, B, C. So light is getting totally internally reflected like this, suppose. So this is your normal. Now this angle is 45 now. This angle will become how much? 45. This is 45. This is 75. So this became how much? 5, 5, 10, 120. So this became 60. Again, this became 30. So checking for surface AD, what will be the critical angle? Again, critical angle will remain the same as the surface CD because it's also CD पे total internal reflection होगा या नहीं, that you need to check ना. So here sin 30 value will be how much? You just need to check here. Critical angle we have already got now. Sin IC value was 1 by root 3. So if this angle is greater than critical angle, total internal reflection will happen. Done. And if this angle is less than critical angle, total internal reflection will not happen. Again, check it here. Will it happen or not? You just let me know now. Angle is 30 degree. So sin 30 half. And for critical angle value is how much? 1 by root 3. So tell me now. Will it happen or not? क्या हो गया? Why this much silence? You just need to see the geometry. What will happen? I have given you everything like sin IC is there. Angle of incidence is 30 degree from the geometry. Now let me know if internal reflection will happen on the surface AD or not. That is your question. Answer me within 30 seconds. Tell me now. Yes. Will it happen or not? Total internal reflection will happen. You just check here the values. What I have done previously I have done it now. Like here, sin IC value is how much? 1 by root 3. And here the value will be how much? 1 by 2. Done. So root 3 is less than what? Root 3 is less than 2. sorry, root 3 is less than 2. So 1 by root 3 is greater than 1 by 2. Then 1 by root 3 is greater than 1 by 2. Agree or not? This is true. So if 1 by root 3 is greater than 1 by 2, it means angle of this and will be greater than angle of this. Then, so here angle is this 30 degree is less than what? Critical angle. This 30 degree is what? Less than critical angle, no? Yes. So if it is less than critical angle, then what will happen? It will come out. It won't go, it won't internally reflect, no? What I told you, like critical angle, we have already got sine IC is how much? 1 by root 3. And we know that as angle will increase, sine value will increase. So check the sine value now simply. So sine 30 is this 1 by 2. And sine of IC is 1 by root 3. So 1 by root 3 is greater than 1 by 2. Then, so if this is greater, it means this angle is greater than this. Means angle of incidence is less than critical. It means total internal reflection will not happen. Now calculate the angle of emergence here. So what will be the angle of emergence here? This angle. Apply the Snell's law at this point. What value you are going to get? So here I am going to apply sine 30 into root 3 will be equal to what? Sine E into 1. So how much this is? Root 3 by 2 sine E. And this is equal to how much? 60 degree. So angle of emergence is how much? 60 degree. Then now what is the options? The ray gets totally internally reflected at face CD. Yes. Ray comes out through face AD. Yes. The angle between incident ray and emergent ray is. Now we have to calculate the angle between incident and emergent ray. Done. Again, do it very carefully. What you have to do, this is the angle of emergence. Sorry, this is the emergent ray. And this was the angle of incident. Just let me remove everything out from here. Then just to show that thing clearly, because that I need to do actually. So what was happening? यहाँ से light ऐसे गया, this got totally internally reflected. Now this is coming out. So we have to calculate the angle between incident ray and emergent ray. Now parallelly we can translate the vector. Let's take this vector here. This vector I have taken here. So we have to calculate angle between these two. What will be this angle? That we need to see carefully. So angle between incident ray and emergent ray should be what? Done. What it should be? Just you see, this is with vertical. This is making how much angle? This had made 60 degree now. So this angle is how much? This was your. This angle will be how much? With vertical, it was making how many angle? How much angle? 60 degree. Done. So this angle is your 60 degree, and this angle was how much? You just see the things carefully, huh? You just need to calculate angle between these two. So by geometry, you can do that. Now, done. I don't want to mess up with the geometry. Clearly draw it and you will be able to see that. So it will come as 90 degree, I guess. Done. Chalo, theek hai. Now, anyone having any doubt in total internal reflection thing? I hope you all will be able to do that. You people are doing what, I guess, na? You people are not looking at the geometry carefully. You just have to draw the geometry things perfectly. You have to see like how to apply the Snell's law that you already know. So you need to just use a step by step and move ahead. Then and draw the diagram clearly, because if you're messing up with the diagram, no, things might go wrong. So with the diagram, you need to be very much careful. Chalo, do this question now. Take another 3.5 minutes I'm giving and do it. Okay, let's do it a bit later. Okay, chalo, thoda sa easy hote hain. So I will come back to that question again. Okay. Now let's do this question. For lens, what formulas you need to remember? First, I need to give that thing. So lens formula you already know. This is this. Lens makers formula you know now. 1 by f is how much? Mu lens minus mu media by mu media into 1 by r1 minus 1 by r2. So these are two basics formula that we will be using for lens. Now do this question. Take some 2.5 minutes or 3 minutes I'm giving. Don't worry. Do it now. Read the question carefully. Do it. Keshav, yes. Other people do it, still having time. Yes, Rapid, no. Check once more. Kriti, are you here? Yes. Is so not there? Okay. One Kriti, Keshav, Rapid, one more with dot dot dot. What's your name? Name used to be our identity now. Keep using that. Chalo, done. So what the question is, there is a Acha, Hariom. Okay, done. So biconvex lens is there with two thin plano convex lens. Then how this biconvex lens is formed? By two thin plano convex lens. So one lens is this, another lens is this, and they are kept very close together such that this vertical line is just coinciding here to form a biconvex lens. Done. So this is combination of two lenses, two thin lenses. Again, done. Refractive index n of the first lens is this, and that of second lens is this. Both the curved surfaces are of same radius of curvature, this. So for this biconvex lens, if object is kept at a distance of 40 centimeter, where the image will get formed. So first try to, you are given what object distance, you have to calculate what image distance, you need to know what focal length. Done. So what will be the focal length of this combination, that we need to calculate. So if we know the focal length of individual lenses, suppose focal length of this is f1 and its is f2. So what will be the net focal length? It will be 1 by f1 plus 1 by f2 with proper sign convention used. Done. This is going to happen. And this is your plano convex lens. This is your plano convex lens again. So for convex lens, sign convention of focal length is what? Positive. Done. So let's calculate f1 first. 1 by f1 will be how much? Mu of this lens mu value is how much? 1.5, and it is kept in what sort of media? If nothing is given, then in air it is kept. So minus 1 divided by 1, mu lens minus mu media by mu media. 1 by r1, its refractive, its radius of curvature is how much? Its radius of curvature is how much? That is given, that is your 14 centimeter. So what the sign convention we are going to get? Positive only. Why positive? Because for this, if you will see, just dekho, I just want you to show that here so that in ahead things you won't get the problem. Suppose this is a plano convex lens, done, and you have to calculate its focal length. So, so for using sign convention, you need to take an incident light. Either you take incident light on this surface or you take incident light on this surface. Either will work. So if you are taking incident light on this surface, this will become surface 1 and this will become surface 2. So for this, if I am applying, I will be writing what? I will write 1 by f equal to mu Lm minus 1, that is refractive index of lens with respect to media, into kya karoge? Radius of curvature of first surface minus radius of curvature of second surface. So radius of curvature of first surface will be somewhere here. So again, it is in the direction of incident light. So that will be taken as positive. R2 is infinity. So this will become, this whole will become 1 by R. Now there must be a question in your head if I'm taking incident light as the opposite. Then suppose I'm taking incident light on this surface, then this will become surface 1 and this will become surface 2. Then, so if now I'm going to use, I will write 1 by f mu Lm minus 1 1 by R1. R1 will be this surface. So its refractive index, once again, you need to check a bit more again. So 1 by R1 will be 1 by infinity minus 1 by R. Minus, and its radius of curvature is here in the opposite direction of incident light. So this will become minus of 1 by minus R. Then, so again, this will become positive. Answer will be same in both cases, 1 by R. So for convex lens, if you are dealing with convex lens, whatever this thing you are going to get, this will always come as positive. Then this will always come as positive. Done. So now let me remove all this. Just I used it to make you understand. So why I will be taking 14 as positive, that is why I explained it. So let's take y as 1 by 14 positive I have taken. Done. So what will be its value? Its value will be, this will become 1 by 2 into 14. Done. Clear? So 1 by f1 we have 1 by 28. 1 by f2, again, that is also plano convex lens. So we will be using 1.2 minus 1 divided into 1 by 40 minus 1 by infinity. Same as that. So what value it will be taking? It will become 1 by 5 into 14. Done. So 1 by f1 and 1 by f2 value now we are having. Yes, once. Correct. Very good. So what 1 by f1 plus 1 by f2 will be now equal to how much? 1 by f1 is how much? 14 into 2. 1 by f2 is how much? 14 into 5. So this will become equal to how much? So if you are going to calculate this, what value you are going to get? This will be 1 by 14 into, if you're going to see that, 7 by 10. So this is 1 by f equal to how much? 1 by 20. So focal length of this combined system will be how much? Its focal length is 20. It means its center of curvature distance will be how much? 40 centimeter, and my object is kept at 40 centimeter only. So image will get formed on 40 centimeters, because if object is kept at center of curvature, it means image will also get formed at the center of curvature on the opposite side. So image distance will remain 40 centimeter positive again, because this is a convex lens. Done. Chalo. Now do this question. Again, question is very easy. I'm giving
Ma'am, for
you
the last
again.
question,
Yeah.
why have we taken F radius of curvature for F2 to be positive?
Which radius of curvature is positive?
For F2.
For f2. Again, that is a convex lens. Now I said you, if you are using, if you are calculating things for the convex lens, just now I explained now. Just say this is this now done. So I told you कि for calculating the focal length, you will use what? Lens maker's formula. So lens maker's formula is what? 1 by f is equal to mu lm minus 1 by 1. Again, this is positive. Leave it aside. Here you will be writing what? 1 by r1 minus 1 by r2. I said you to use which one will be r1 and which one will be r2. So for that, take one line. Huh, you got that?
Yes, ma'am.
Okay, thank you. Chalo, let's do it now. Take 2 minutes of your time and do it. Question is very easy. You just need to apply the formula carefully. And what is the formula for lens maker's formula I have given? Refractive index is written as what? Speed of light in vacuum divided by speed of light in media. And a speed of light can be related with the wavelength. How wavelength is related to speed of light? You all know that a speed of light divided by wavelength is equal to frequency. Done. So velocity can be written as lambda into frequency. And we all know that while refraction, speed changes, wavelength changes such that frequency remains same. Done. So these concepts you need to apply in this question. Do it now. Take 2 minutes, do it. Hello, everyone, try. If you require hint or something, you can ask me in the chat box if you're getting any sort of trouble. Yes, no, Ravi. Check once more now. Question is very easy. Yeah? Image formed by convex lens at a distance of 8 meter behind the lens. Object is kept where? 8 meter behind the lens. Object distance is given in the question now. Yes, Hariom. So object distance is given and magnification is given now. Magnification is how much? 1/3 the size of object. Done. So 1/3 is the magnification. And object distance is given. So image distance we can calculate now. Magnification is what? D by U. And this is how much? 1/3. So this will become how much? P is not known. U is how much? 8. Sorry, 1/3 is real and is 1/3 the size of object. Done. So V will be how much here? V will be 8/3. Done. So this is your image distance. Done. This is how much? This much. Again,
Ma'am,
here what is
U is given it.
What is given?
Ma'am, U is given it or V is given equals to it. Image of an object formed by the plane at a distance of it.
Image distance, no?
Yes.
That is what you said, I guess. Image of an object formed by a plano-convex lens at a distance of 8 meter behind the lens is real and 1/3. Okay. So image distance is given actually. That is your how much? That is your 8 meter. Read the question carefully. That is image distance. And magnification is 1/3. So that is 8U. Now what will be the value of U? That will be your 24. So U is known, V is known. We can calculate focal length, right? So what will be the value of focal length? 1/V minus 1/U equal to how much? 1/F. Now, this is formed, real image is formed now behind the lens.
Magnification is negative for real images.
Yes, that will be negative actually. I have ignored the sign. I've just got the value of this. If you are going to use that, obviously object distance will come as negative. Done. With proper sign convention, object distance will be what? Negative, because there is a plano-convex lens now. Object is kept like this, and image is getting formed somewhere here. So definitely object distance is what? Negative. Taken as negative if sign convention is into account. Now 1/V, image distance is this, so positive. V is how much? 8 minus 1/-24 will be equal to how much? 1/F. So if you're going to calculate that, how much value you are going to get? 4/24 equal to 1/F. So F is how much? 6. That is your 6 meter. Done. So focal length we have got. Now what we need to calculate? Radius of the curved surface. Now use the lens maker's formula. So 1/F equal to mu lens minus 1/1 equal to 1/R1 minus 1/infinity. For plano-convex lens, we can use it directly now. So 1/F is given 1/6. Done. That will be positive only. From here also we have got it positive only. And mu L is how much? What is the refractive index of mu? No, that is not given. So what is given? Wavelength of light inside the lens is 2/3. So wavelength of light is 2/3 of that in vacuum. Done. So calculate the refractive index. That is equal to how much? C/V. Now C can be written as what? Lambda naught F by lambda F. Done. This can be written as this now. F got cancelled. Now lambda value is how much? This is 2/3 of lambda naught. So lambda naught by 2/3 of lambda naught. Again, this will get cancelled, and you will get how much? 3/2. So what is the refractive index here? 3/2. minus 1, and that is 1 by r, because 1 by infinity is 0. So now 1 by 6 will be equal to how much? 1 by 2r. So r value is how much? 3 meter. Done. So only you needed to move just step by step ahead, and you will end up getting the answer. So this is your answer. Now, this is the question. Silvering of lenses we have already discussed. Again, what you need to do here is read the question very carefully, I will say. Again, concept is very easy. Whatever you have learned, you just need to apply that with patience. So with patience, first read the question, then apply the concept and try getting the answer. I'm giving you 3.5 minutes. Okay? So do solve it. और किसी को बीच में कुछ भी doubt हो, you can ask me in between also. Done. First read the question for 1 minute. Then I will explain it also so that you will do it. Chalo, read it now. हाँ, once last question का आंसर तो 3 ही था ना. I told you all, no? 3 meter. You see here, 1 by 6 equal to 1 by 2r. So 2 3 times से cancel होगा ना. So r value will be how much? 3 meter only. Everyone has read the question now, till now? Done. So what I want to explain is, just see carefully. Initially, what the system is, there is no liquid code here, and system looks like this. Initially, a pin is kept at 18 centimeter, and its real image is getting formed at A itself. Done. So initially, if I am going to draw it like this, my lens is this, and it is kept on a surface which is silver. So if you consider it like this, what will happen? If this is the object, light will go from here, refract and fall on this. Then, so you can consider, because what happens now, aperture of lens used to be very small. Done. This aperture is very small. Done. So whatever light is falling on this has a chance of meeting this surface. Are you getting my point? I am saying that this wala length na is very small. Just let me show you one thing. I have told you to do the last question of NCERT. That has the same concept actually, but I don't know how many of you did that. So I'm saying that lens aperture used to be small, so this portion is very small. Done. This portion is very small in comparison to this whole portion. Done. This whole portion. So whatever light is falling on this lens, refracting inside, has more chance of falling on this silvered portion. So what will happen now? Light will go inside, it will refract, and it will fall on this mirror kind of thing, and again get reflected, come out. So this lens in first case is acting as a what? It is acting as a mirror. Again, it is acting as a mirror, and here there is a air only. Now this space is what? Air only. Done. So this kind of thing is happening here. Matlab, you can simply consider that this is a lens and it is silvered at this post. Done in first case. In second case, what is happening? When a liquid of refractive index mu L is put between lens and the mirror. Between lens and mirror, initially lens and mirror was just connected. There was air in between, nothing else. So it is acting as if this is silvered. Now in second case, what is happening? We are filling this entire system with a liquid. This entire system with a liquid. So what things it will look like? It will look like something. This space is getting filled with water, no? This space is getting filled with water, and this is silver. Initially, it was air. So we were just considering that this surface is silver. Now this will look something like this. Again, it will be a lens. It will be a lens, and this surface will be silver. Done. So initially, it is a lens silvered at another surface. Now it is not a single lens. It is two system of two lenses, out of which the last lens has its plane surface silver. Done. So consider it like that and then solve. For this, try to calculate the focal length. For this, try to calculate the focal length. In both cases, image is getting formed at the object only. So for first case also, this 18 centimeter is what radius of curvature value, yani ki double the focal length. And in second case, 27 centimeter is also double the focal length. So try to calculate the focal length. Done. Do it now. When liquid will come in between now, it will also form a lens actually. When there was no liquid, no other lens. Yes. Yes, very good. What's your name? A student with millions of dreams. Yes, we all could have dreams. You know, I have very much wild love for dreams. I dream just any random thing and then believe like I will have it one day. And that happens, you know. So we should dream always. We should be in the dream world. And for that dream world also, we should work. We should work also wildly, the way we are dreaming. You know, everything is possible. We just need to believe. Chalo, how many of you have got the focal length of first system? First system was like this now. Just tell me what focal length you have got. The one you have got the answer now. What was the focal length of this? Again, light
मैंने
will
सॉल्व
go
नहीं किया, बस
inside.
मैंने ऑप्शंस एलिमिनेट किए हैं बस इसमें.
Acha. That's also great. But how you eliminated the options?
मैम अगर वो रिफ्लेक्ट करे तो उसका रिफ्लेक्टिव इंडेक्स कम आना चाहिए बाकी से. तो जो 4/3 है उसका जो वैल्यू है वो सबसे कम आ रहा है.
अच्छा.
ऐसा क्वेश्चन हमें करवाया था एक बार सर ने, यश सर ने.
Done. If you are able to eliminate, that is good. Clear है सबको? We can quickly solve it also. Like if that comes wrong, because not always we can go with that actually. So we need to know the concept also. So elimination thing you can do, like you can check with the geometry and all. But if that is not as striking, this calculation is also here very easy. You just need to write the focal length formula. So that I have already given to you in the previous class. What was that? This will act as a mirror. So focal length of mirror minus 1 by f will be equal to 2 into focal length of lens here. Done. 2 by focal length of lens, because twice refraction will happen. Once, what is happening? Reflection. Done. And here reflection was happening from what kind of surface? This surface was what? This surface was planar now. Done. This is a plane surface. So here, this was a plane surface here. So we can take its focal length as what? 1 by infinity. So you just need to solve this here. And what will be the focal length of lens? Is it given? Is it given or not? No, but the focal length value is given here now. In the first case, what is happening? Image is getting formed at 18 centimeter. It means this is center of curvature thing. So focal length will be half of it. So from there you can write, if I ignore the sign convention, I can write that 1/9 will be equal to 2 by f length. So f length we can write as what? F length will be equal to how much? 18. So f length is 18. Now if f length is 18, you can calculate its what? Radius of curvature or something. Then what will be the radius of curvature here? This was a lens now. So its focal length is 1/18, and that will be equal to 3/2 minus 1 because its refractive index is this. And both will have same radius of curvature
ma'am.
because this is a yes.
Ma'am, why
Anything to
focal
say?
length 18?
What?
Ma'am, focal length 18 क्यों हुई?
Yes.
Focal length 18 कैसे आएगी?
कैसे आएगी? I have discussed in yesterday class na silvering of lenses. So if you are silvering lenses, what it will act as a mirror. So if it is acting as a mirror, this whole this whole system is acting as a mirror, and for mirror power used to be what? -1 by focal length of the mirror. So I have taken -1 by focal length of this whole system will be equal to, now see how many times light is getting refracted. So that many times we will be taking the focal length of lens or power of the lens, plus see how many times it is getting reflected. That many times we will consider the power of mirror. Done. So the basic logic is what I am doing. I am looking at the power of mirror will be equal to number of times it is suffering refraction into power of lens plus number of times it is suffering reflection into power of mirror again. So this will be again minus, and power of mirror used to be what? -1 by focal length. So I took -1 by focal length. Again, if this system is acting as a mirror and if object is
1/9 कहाँ से
18
लेके आए मैम
centimeter,
आप इसकी जगह?
yes.
आपने टोटल के लिए लिख दिया ना, पूरे सिस्टम के लिए आपने 1/9 लिख दी फोकल लेंथ, कैसे?
That I'm explaining now. So if object is kept at how much centimeter? 18 centimeter पे रखा हुआ है, and it is kept that image is getting formed at the same distance also. So if this is acting as a mirror, object and image distance are coinciding. It means this whole length is how much? Radius of curvature. Done. So radius of curvature is how much? 18 centimeter. It means focal length of the system will be how much? R/2, that is 18/2. So that will be 9 now. Done.
Okay, ma'am.
Got it? Yes. कोई problem है? Okay, done. So 1/9 is 2 by f length. So f length is 18. Now I'm going to calculate the radius of curvature of this. Why? Because that will come into application in the second portion. So 1/r minus 1/r. Again, you will be writing this. Done. I'm writing directly because I am assuming that you know how to apply the lens maker's formula for equiconvex lens. Done. So 1/18 will be equal to how much? 1/2 into 2/r. So 2 got cancelled. So R value will be how much? 18 centimeter. So here radius of curvature for the lens is also how much? 18 centimeter. Now come to the second thing. In second case, what was happening? There was a lens like this also. It was having refractive index N1, it was N2, and this surface was silvered. Now we have to calculate the focal length of this system. Again, light will go inside, refract from the first surface, from second surface, again here, and reflect from here, and from here. So from this surface, it is refracting twice, and from this surface, it is refracting twice, and it is reflecting once. So this whole will act as a mirror. So power of mirror we will write as 2 into power of first lens plus 2 into power of second lens plus 1 into power of mirror. That we are going to do, right? Now power of mirror, again, that we know in the according to the question, that is given as how much? Like if object is at 27 centimeter, image is getting formed at 27 centimeter. It means its focal length will be how much? 27 by 2. So what I am going to write here, 27 by 2 equal to 2 into power of first lens was how much? How much was the focal length of lens? 18 centimeter. So what I am going to write, 2 into 1 by 18 plus, because this is a convex lens. Now, let me write this portion, minus 1 by infinity, and again 2 into 1 by focal length of this lens that we don't know. Done. So from here you can write, you can calculate the focal length of this lens. Done. You can calculate now which lens? This lens. So if that is that you are getting, then again you write the focal length of this lens value. So 1 by f lens will be equal to how much? That will be equal to mu of this lens, that is your mu L minus 1 by 1 will be equal to how much? 1 by R1 minus 1 by R2. So take the incident light like this. So 1 by R1 will be taken as what? Negative, minus 1 by R1, or यहाँ पे minus 1 by infinity. So you know R1 value, that is 18 centimeter. You know FL from here, mu L you will be able to calculate. Done. So if your calculation, like if your concept is clear, directly you will be simply putting the values and getting the answer. It's not that much time taking. If you are free with the calculation and free with the concept. Okay? Clear everyone? An answer you will be getting will be 4 by 3. Done? Chalo. Okay. So this is also a question. Again, you will be able to solve it by using the lens maker's formula. This question I want you to solve. Take some 3 minutes and do it. Because previous question, again, you have to apply only what? Lens maker's formula. And you have to just see, keep on seeing the values and using it. Done? So question is very easy. This one is a little bit different. So try it. Take some 3 minutes and do it. Intensity आप लोग जानते हो ना? Just I will be keep on giving hints only so that you can solve. Intensity is what? Energy per unit area per unit time. Done. So just I'm giving the hints. So if this is a lens, and what is happening? Light is coming. Done. So this light will have some intensity. Done. And it is passing through this lens. So how much power will pass through the lens? Whatever is the area of this lens. Done. So if its area is A, then how much light will pass through it? I into A. That power of light will pass. Done. And from geometry, you know that if this is the principal axis, light coming will converge at the focal length. So all this power will converge at this point. Again, all those light will go on like this. Done. So if you have to calculate intensity now at any other distance, what you will be doing? Here, suppose power coming to the focus is P, and suppose this is at a distance R. So intensity will be how much at this distance R? You already know na, if there is a point source and we have to calculate its intensity. Yes. So that will be equal to how much? P by something 4 pi R square करोगे आप यहाँ पे, है ना? So this will be how much? P divided by some 4 pi R square वाला concept, somewhat. Done. So it will get related with the R square. No? So just try utilizing all these concepts. Chalo, I've given you hint. चलो मैं इसको एक्सप्लेन करती हूँ, ठीक है, नो वरीज, लेट मी एक्सप्लेन इट. सो व्हाट इज हैपनिंग हियर, वी विल गो विद द कॉन्सेप्ट only. Sunlight of intensity how much, 1.3 kilowatt per meter square is incident normally on a thin convex lens of focal length 20 centimeter. Done. So focal length given is how much, that is 20 centimeter. Yani ki this distance is how much, 20 centimeter. Ignore the energy loss of light due to lens. No energy loss we have to consider into account, and assume that the lens aperture size is much smaller than its focal length. Lens aperture size is what, much less than that of its focal length. The average intensity of light at a distance of 22 centimeter from the lens. So we have to calculate what will be the intensity of light at 22 centimeter, means from 2 centimeter from the focus, yani ki somewhere here 2 centimeter. If this R is 2 centimeter, then we have to assume that if there is a lens kept at here, then what intensity of light will pass through this lens or this curvature if I am taking whole into account. Then what will be the intensity? Done. So how we are going to solve? If we somehow know what power is coming to the focus, we can easily calculate this, right? So what power will come to the focus? Again, we have learned in lenses that if this is the lens and this is its aperture, suppose this distance is how much, this is D, and this distance is how much, D. This both distances are what, suppose D. So if you already must have studied that correction wala thing in wave optics. Done. So if this is the focal length and this angle is theta, then tan theta can be written as what? Tan theta can be written as D by F. D by F. So D will be equal to how much? F tan theta. Again, it is said that aperture is very small with comparison to the focal length. Means F here is far greater than D, right? If that is true, F is far greater than D, so this is very small, no? Tan theta is small. And if tan theta is small, tan theta can be written as theta. So D can be written as here F theta. So now I note the radius of curvature here. That is, sorry, this half length of the lens. That is how much? F theta. And you must have studied there, if light coming is I, if I intensity of light is coming, then we can assume that, we can say that how much power is getting captured by this aperture, that will be equal to area of this lens into intensity. Done. And its area will be parallel to the square of this P. Done. Because this is taken as the radius of the aperture. Done. So this is equal to some constant K I am taking. I'm not going into that deep, but that will also take care of our question. K into D square into I. Done. So this is the power reaching. And here D square will be equal to how much? K F square theta square into I. So this much power is reaching at the focus. Now, power we understood, this much power is reaching at the focus. Now, what will be the intensity at 2 meter or 2 centimeter? Again, this angle is how much? This angle is how much? Theta. If this angle was, suppose, if this angle is taken as theta, this is also theta. So this is also what? Theta. From the symmetry and geometry, this is theta again. So this is theta, this is 2. Done. So what aperture we can take it here like that. Similarly, like lens only calculated for the ease of calculation, for just translating this calculation to there.
Around 1300 or 130 kilowatt.
Yes, yes, correct. Thank you. So how much height? Sorry, I was going to calculate what I forgot. The aperture here. So suppose this is A. So A by 2 will be here tan theta. For the second case, I'm going. So A by 2 you will be taking as what? A by 2 you will be taking as tan theta. Again, theta will be small, so theta. A will be equal to how much? It will be equal to 2 theta. Again, what will be the intensity here? Intensity is written as, intensity I'm writing here as, what I will be writing? What I should write? Batao. Intensity should be written as power per unit area. Done. So how much is the power? Power we have already calculated, K F square theta square into I. So KF square theta square I divided by area. So area again, A is parallel, A is equal to 2 theta, and area I have taken as some constant into that aperture ka square. So that I can write here K into 4 theta ka square. Again, K got cancelled, theta got cancelled. So answer will be what? F square by 4 into I. So if you are going to calculate F square into I by 4, so how much you will be getting? This again 4 I have taken centimeter square. So F square is 400 by 4 into I is how much? That is 1.3 kilowatt. So convert it into watt. So 1.3 into 10 to the power 3. So what answer you are going to get? 130. Done. So that will be your logic. This is the way we solve such questions. Done. So whatever power intensity is coming to the lens, how much power it will capture, that intensity into area. Area will be proportional to the square of its aperture. Done. Clear? Square of aperture of lens is taken as this whole length. Done. So I have simply taken the radius of aperture as this half. But in short, what you can say, power getting captured by the lens is directly proportional to the square of its aperture. By using that concept, you can solve this question. Simple. Okay. Chalo. Again, this question is very easy. Let's do it or what? Yeah, there was a match column. I have added 2 or 3. But that I will do tomorrow. चलो ये question कर लेते हैं, ठीक है? So let's take some 2 minutes of time and solve it. Again, this question is very easy. You just need to use the basic formulas, nothing else. For 3 minutes I am giving. Don't worry, 3 minutes I have given to you. Solve it. This is a two configuration system. Like there is one mirror and one lens. So net magnification you will be calculating how? First you will see ki what magnification mirror is giving, what magnification lens is giving. Suppose one is giving small m1, another small m2. So total magnification will be how much? M1 into m2. That's the concept now. Done. So that you will do. And in second case, what is happening? Combination. Like in second case, this lens is being kept in a media which refractive index is 7/6. Then for in that case, you have to again calculate the magnification, because if this lens is kept in a media of refractive index 7/6, its focal length will change. Done. If it is in air and if it is in this media, in both cases, its focal length will what? Change, and hence its magnification also. So let's solve it. Okay, चलो मैं करती हूँ. So what you needed to do is, in first case, what is happening? An object is kept at a distance of 15 centimeter. Separation between lens and mirror is constant, that is 50 centimeter. And in first case, lens is kept in an air media and its refractive index is 1.5. Done. And both has a focal length of 10 centimeter. Both has a focal length of what? 10 centimeter. Now, let's see in first case, case 1, I am going to deal with. So in first case, magnification by mirror we need to calculate. So calculate the image distance. 1 by v plus 1 by u equal to 1 by f. This is a concave mirror. Done. So 1 by v we don't know, plus 1 by u. U is how much? 15 centimeter minus 15. And its focal length will take also negative value, minus 10. So 1 by v is how much? 1 by 15 minus 1 by 10. So this will become something like this. So this is going to be minus 1 by 30. So at 30 centimeter, it will form the image. So image formed by mirror will act as a, it is getting inverted image will get formed. So this will act as an object for the lens. So this is at 30 centimeter from here. So from lens, it will be at what separation? From lens, it will be at 20 centimeter. Done. So this is 30. This will be what? 20 centimeter. Now let's calculate first the magnification by mirror. So magnification by mirror, we will write as minus v by u. So v is how much? That is your how much? Minus 30. Done. And what is u? Minus 15. So magnitude, if I consider, that will be 2. Minus sign will say that image formed is inverted, right? So magnification by mirror is 2. Now in case 1 only, let's calculate the magnification by lens. So what will be the magnification by lens? Just give me 1 second. Yeah, एक second. Done hai. So in first case, mirror ke, in the case of lens, what will be the magnification? So just calculate the image distance again. So 1 by v minus 1 by u. What is the value of u here? That is your minus 20 equal to 1 by f, that is 10, plus, because this is a convex lens. Again, what will be the value of v? 1 by 10 minus 1 by 20. So this will become how much? This will become 1 by 10. So what is the magnification here? 1 by 20. So image distance is how much? 20. Object distance was how much? 20. So magnification by lens is how much? 1. In the case 1. Done. So net magnification in first case, that is M1 will be equal to 2 into 1. That is 2. So M1 value we have got. Now in the second case, magnification by mirror is not going to change. Magnification by mirror is not going to change. Then that will be again same as minus 2. But for the lens, what kind of thing is going to change? This is going to be kept in a media which refractive index is how much? 7 by 6. How its focal length will change? Now, initially what was happening, its focal length was 10 and its medium is this, its refractive index is this. And suppose it is having radius of curvature as R1. Because this is an equiconvex lens now, modulus of R1, R2 will be equal. So this will become 2 by R if you take the properly the sign convention for convex lens. So 1 by 10 will be equal to, this is 1 by 2 into 2 by R. So R value is going to be equal to what? 10. Always remember that for equiconvex lens, radius of curvature will be equal to focal length if refractive index of the lens is 1.5. That generally happens. Done. So R is 10. Now, why this R was important? For calculating the focal length when lens is kept in another media. Now, new focal length will be, suppose 1 by f. So mu lens 1.5 minus 1.5 means how much? चलो मैं इसको ratios में लिखती हूँ. So that will be taken as what? 3 by 2 minus 7 by 6 divided by 7/6 into 2/r, and r is 10. So this will be the new focal length. And if you are going to calculate it, this will become how much? 2/6 into 7/6 into 2/10. So this is 6/6. And this is going to be how much? 4/70. So this is the focal length, 4/70. Done. Now you need to calculate the image distance, new image distance. So 1/v minus 1/u equal to 1/f. 1/v we don't know. 1/u, object distance was how much? 20, equal to 1/f. That is equal to how much? 4/70. Done. So this is the thing. Now you need to solve it. 1/v equal to 4/70 minus 1/20. So just go for this calculation. This will become equal to how much? This will be 1/140. Done. So V is how much now? 140. So now magnification by lens is how much? Image distance, that is 140 by object distance, that is equal to 7. So new magnification by lens is how much? That is 7. So M2 value will be how much? M mirror into M lens, and that is 2 into 7. So 14, initially 2. So 14/2, 7. So correct answer will be 7. Okay. So I hope this is clear. In the next class, I will be taking a few questions from wave optics, and mostly we will be covering wave optics. But please try solving more and more previous year questions and more good questions, so that you can get hold of all these things. Match columns I have added 3 just for the general revision of all the topics of wave optics. That we will be doing in the next class. And we will be largely considering wave optics. Okay. So you all stay safe, stay healthy. I'm already running 5 minutes.